Welcome back to Algebra 1. We're going to take a look at just reviewing something you've already done, simplifying radicals, and we're going to focus on the kind that we will simplify for quadratic equations. So we don't have to worry about cubes or quads. This is the main list of squares and square roots from 1 to 20. And anytime that we know the square of a number is like 16, then we know the square root of 16 is going to be 4. These are referred to as our perfect squares. And they do continue, but these are the ones we'll be using most. So when we simplify perfect squares, if we have a perfect square, that's great. We can just say, I recognize this is 6. But if we don't have a perfect square, nothing that's on that list, we had 81, but not 80, we're going to have to start factoring. And it's still underneath the square root sign. I usually make a long square root sign. And I might recognize that this is going to be 16 times 5. You might not recognize that 16 goes into this. You might recognize that 8 is divisible by 4. So I could have said it was 4 times 20. But then I recognize that 20 has a perfect square in it. So I keep going. 4 times 5. Both of these are perfectly okay. The goal is get perfect squares underneath the square root sign because each perfect square I get to do. So I can think about this as separating the square roots out like this and doing anything I can do, so that would end up being 4 times the square root of 5. If I did it this way, I know the square root of 4. I have another square root of 4, finishing off with the square root of 5. In this case, the square root of 4 is 2. The square root of the next 4 is 2. The square root of 5, I don't know. Sometimes you will hear me say, heck if I know. And that tells me I'm going to leave it under the square root sign. And I end up with the exact same answer both ways. 8 is not a perfect square, 9 is, but it's not 9. So it is divisible by 4. 4 times 2. I don't often write this next step, but just to make sure that you know that's what we're actually doing. The most common mistake I have is people take a square root and then they leave it under the square root sign, so they really change the problem. This becomes 2 times the square root of 2. Do we know the square root of 2? Heck if I know, so we keep it under the square root sign. Continuing. I'm always looking for things that are divisible by a perfect square. This is 4 times 3. Those are underneath the radical. I can separate them out to make sure that I know which parts I'm doing. I know the square root of 4, square root of 3, heck if I know. Leave it underneath. Again, I might not recognize the largest perfect square that goes into something. This is divisible by 9 because 1 plus 8 is 9. And anytime I add the digits, I can find that 9 goes into it. So that becomes 9 times 12. Oh, but 12 has perfect squares in it, so I'm going to cross it off and change it to 4 times 3. So splitting these up, again, I don't always write this step. I'm doing it to make sure I know which parts I'm doing. And then I'm going to take the square root of everything I can. Square root of 9, square root of 4, square root of 3, heck if I know. That becomes 6 times the square root of 3. Everything I leave on the outside, multiply. If I have more than one thing on the inside, multiply those. This is divisible by 25. And the square root of 25, I know. The square root of 2, heck if I know. These are all considered simplified. Now, you can happen to find a perfect square, nothing wrong with that. You don't have to have a square root in your answer. So the square root of 64 is 8. I can also, this isn't divisible by 4, it's not divisible by 9, it's not divisible by 16, not divisible by 25. Once I go through that list, I might recognize there are no perfect squares in it, or I could factor this guy out completely. 3 times 10, 10 is 5 times 2. But do I see any perfect squares there? Do I know the perfect square of 3? 5, 2. There are no perfect squares that divide into this. My answer can be my question. I couldn't simplify it anymore. So that can happen. Square root of 18. I recognize 9 goes into that. Times 2. Square root of 9 is 3. Square root of 2. Heck if I know, leave it underneath. This is the form that we're working on because this is what we will see when we solve quadratic functions in other ways. So your homework is on Google Classroom, and have a good day.